everyone. Last class I explained how to find maximum shear force and maximum bending moment in the case of UDLs. Okay, and also we have seen how to find shear force and bending moment when the UDL is longer than the span. Today we will see if the UDL is shorter than the span. Let us take this problem. An uniformly distributed load of 40 kilonewton per meter intensity and 6 meter long crosses a girder of 25 meter span. Calculate the maximum shear force and bending moment at a section 10 meter from the left end support. See students, you have to make out whether it is longer than the span or shorter than the span. It will not be specified. Okay, see this example. In this case, 40 kilonewton per meter intensity and 6 meter long, and girder is 25 meters. So the span of that girder is more than here this UDL length. UDL length is 6 meter, but span length is 25 meters. So it is shorter than the span. You have to assume. Okay, how to find? First, you have to place UDL for negative shear force, and then for positive shear force, and then for bending moment. Okay, for where negative shear force is induced. Negative shear force is induced when when the head of the load is at the section. So you have to start from here. So what is the distance? It is only for 6 meter length. So now let us consider AB beam of 25 meter span. Okay, and it is asked to find section at a distance of 10 meter from the left end. So section is located at a distance of 10 meter. So what is the remaining distance? 15. So AX is 10 meter and XB is 15. Now you have to put this UDL on the simply supported beam. How it is? Only 6 meter. Okay, so total it is 10 meter. So this UDL length is 6 meter. So this remaining is 4 meter. So this is A, this is X, and this is B. So I'll name it this point as C. Okay, this is negative shear force. Then positive shear force, how it is? When the tail of the load is at the section. So you have to start from this section. It is moving like this, like this, like this till 6 meter. Okay, total length is 15 meter here, but it occupies only 6 meter distance. So mark that point. So this point is name it as D. Okay, so total it is 15. So this is 6. So this remaining distance is 9 meter. Next, negative shear force over positive shear force over. Next, bending moment. How it is? You have to, I told in the last class also, negative shear force and positive shear force is same in the case of both longer than the span and shorter than the span. But you bending moment, you have to assume in the case of shorter than the span, what is that? Maximum bending moment for load should be placed in such a way that the section divides the load in the same proportion as it divides the span. So you have to find this ratio. What is this Cx and what is this Xt? So it means it is load is placed in such a way that that load divides, that section divides the load in the same proportion as it divides the span. Okay, so for this what you have to do? I have told some graphical this expression. For that I will take this is one of the relationship. What it says, Cx divided by Ax is equal to CD divided by AB. So this relationship I will take. Okay, Cx divided by Ax equal to CD divided by AB. Okay, so what is Cx? Cx we don't know, we have to find that. And Ax, what is Ax? A to X distance is 10 meter. So that is 10 meter equal to CD. CD, this UDL of length, it is 6 meter. So 6 divided by AB. AB is full length, that is 25 meter. 25. So if you substitute in this, you get Cx is 2.4. So Cx is 2.4, and so you can find what is xt, because total it is 6. 6 minus 2.4, that is equal to 3.6. So xd is 3.6. So now you know what is Cx and what is xt. This is the first step. After that, then based on this, you have to draw ILD. Okay, for shear force, this is the diagram. At the section, you will have two values, and for the bending moment, maximum at the section. Next, you have to find these ordinate values. How it is? See, this for negative shear force, left portion, extend this portion, so you get this point. So that is C. Okay, you have to find this point. Next, at X, what is at X? Next, positive shear force, that is right portion. So consider this side, XB. So at X, what is that? Then at D, what is that? Find that. Then bending moment, for ILD for bending moment, here also extend this under this, that is at C, and then it is X, and it is D. So how we will find? It is same like how ILD for shear force. Let us consider first portion AX. So what is that? Means unit load is now between A and X. So what is shear force at X? Unit load is here. I consider this side. What is that? Shear force at X is minus RB. So Vx is minus RB, that is equal to minus Y by L. Now find at different points. First point at A. What is Y? Y equal to 0. So VA is equal to 0. Next point at C. What is C? So total it is 6 meters. So this length is 6. So remaining is 4. So at C, Y is equal to 4. So substitute in this, you get minus 0.16. Next point at X. What is Y? Y is equal to full this distance, that is 10 meter. So you get minus 0.4. So left portion is done. Then go to the right portion, that is unit load is in between X and B. So what is shear force at X? Unit load is now between X and B. So I consider shear force at this side. Shear force at X is equal to RA. RA is equal to L minus Y divided by L. Then find at different points. Now you have to refer this positive shear force at X. Y is equal to this distance 10. Y is equal to 10. Substitute in this, you get 0.6. Next at D. What is at D? Till here it is 10, then plus 6, 16. So at D it is 16. So substitute in this, you get 0.36. So at here it is 0.36. Next at B. So Y is equal to full distance 25. So if you substitute in this, you get 0. So ILD for shear force is done. Then go to ILD for bending moment. Again, first consider left portion. AX means unit load is now between A and X. What is bending moment at X? So unit load is here. I consider this side. So that is RB into 15. RB is equal to 5 by Y by L into 15. So find at different points. Now you have to consider bending moment diagram. Okay, so at A, Y is equal to 0. So substitute in this, you get 0. Substitute in this, you get 0. Next at C. What is at C? This point. Okay, you have to refer bending moment diagram. Okay, at C, see total this is 10 meter. Total this is 10 meter distance. This we calculated, that is 2.4. So 10 minus 2.4, that is equal to 7.6. So at C it is 7.6. So you have to see the difference. At C, shear force and bending moment values are different. Okay, so that you have to remember always. In the case of UDL, for negative shear force, you have to refer negative shear force diagram. For positive shear force, you have to refer positive shear force diagram. For bending moment, you have to refer bending moment diagram, because each distances are different. Okay, now at X Y is equal to 10, that is same. At Y is equal to 10, if you substitute in this equation, you get mx is equal to 6. Next consider right portion, that means X and B. Okay, so now what is bending moment at X? Now unit load is between X and B. So I consider this side, that is RA into this distance, that is 10. So RA is equal to L minus Y divided by L into 10. 10. Next, find at different points. At till x it is done. Next we have to see x to b. So at x y is equal to 10. At x y is equal to 10. So substitute in this equation. You get y md is equal to 4.5. At x is equal to 6. Next point at d. So at D is here. So what is that distance? Till here it is 10 meter. So 10 plus this distance, that is 3.6. So 10 plus 3, it is 13.6. So substitute in this, you get 4.56. Next at B. So Y is equal to full distance now, that is 25 meter. So that is equal to 0. So now you got all the ILD values. Now just transfer this value into the diagram. So okay, first the shear force at A it is 0, at A it is 0, and at C it is minus 0.16. So below the line negative minus 0.16. Then at X it is 0.4 minus 0.4. So I have written here 0.4. Then positive shear force at x it is 0.6, at x 0.6, then at d it is 0.36 here, 0.36. At the section you should get both the values equal to 1. So shear force, ILD for shear force is done. So next ILD for bending moment. So that is at A0, then at C 4.56, at C 4.56. Below this line is drawn 4.56. Next at X it is 6. Okay, at X 6. Next then at D, next point, that is right portion. Again consider right portion. At X it is 6, and at D it is 4.56, and at B it is 0. Okay, so once it is done, then next you can calculate what is maximum positive shear force, negative shear force, and bending moment. First we will see what is positive shear force. What is that? Intensity into area of ILD covered by load. Now what is intensity? Intensity is equal to 40 into area of ILD covered by the load. Now positive shear force, you have to refer positive shear force diagram. This portion you have to refer. So what is this area of ILD covered by the load means? This is the positive shear force diagram. So you have to refer this portion. So this is area is trapezoidal. So how you can calculate 0.6 A plus B divided by 2 into L. So 0.6 plus 0.36 divided by 2 into this distance. What is this distance? L, that is 6 meter. So here 40 intensity into 0.6 plus 0.36 divided by 2 into this length, that is 6 meter, that is this length 6 meter, here to x to d 6 meter. So substitute, you get this answer. Next, negative shear force. Again same formula, intensity into area of ILD covered by the load. So what is intensity is 40. Now you have to refer this portion C to X. What is that? Area of this portion is trapezoidal. So A plus B divided by 2 into this length. Okay, what is that? C is 0.16 plus 0.4 divided by 2 into this distance. What is that? That is 6 meter. So here 40 into, it is negative, that's why I have written minus, 0.16 plus 0.4 divided by 2 into 6. This UDL length is 6. So you get this answer. Next, maximum bending moment. What is that? Intensity into area of ILD covered by the load. Intensity is same 40. Now area here, what you have to do? Here this is one portion, this is one portion. So I consider first this portion. So 40 into that full bracket into this area, 4.56 plus 6 divided by 2 into this distance. What is this distance? That is 2.4 into 2.4 plus, next is this diagram, 6 plus 4.56 divided by 2 into this distance. What is this distance? 3.6. Okay, equal to this answer. So what you have to do? You have to consider this trapezoidal area separately. So intensity is 40 into area 4.56 plus 6 divided by 2 into this length, that is 2.4 plus 6 plus 4.56 divided by 2 into this length 3.6 overall multiplied by intensity 40. So you get 1267.2 kilonewton meter. So in this way you can calculate what is positive, negative and shear force and bending moment. Okay, so only